Hey there, this is Kung Fu Physics. This is going to be a very quick edition. I have been driving for about 8 hours total today, so I'm exhausted and ready to go to bed. But I do want to get a quick problem out there, so I've grabbed a quick one. It's kind of a mechanics problem, but kind of also an astrophysics problem, for what it's worth. It's an easy one, very easy. Number 19. This would be off of the 1992 exam. 1992. Quick glance at the answers. It's just a 6 multiplied by 10 to the something, so it's clearly an order of magnitude type of calculation. Sorry, it's hard to read on these green cards for the 92 exams, but let's just do this quick. Which of the following is most nearly the mass of the Earth? And in parentheses, the radius of the Earth is about 6.4 times 10 to the 6 meters. Okay, so easy way to do this problem is to have the mass of planet Earth memorized. If you have that, bomber proof, and you know that off the top of your head, free point. Hey, bank it if you know it. I would recommend memorizing both the radius of planet Earth and the mass of planet Earth, among maybe some other physical constants. And I think I will do at another point in our video about some useful physical constants that I plan to memorize and maybe suggest that other people do too. However, that being said, there is a quick way to solve this problem just by what's given on the paper with a couple of equations that you're very familiar with. And that is just equating the force of gravity via Newton's law of gravity with just your plain old force equals mass times acceleration, where you're using acceleration at sea level, g. So it's the same force, right? So your force equals mg equals g little m big M over r squared. This is the same force, of course, caused by planet Earth. To calculate this force, you just basically can shrink down planet Earth and treat it like a point mass at that radius, and use Newton's law of gravitation to get that. So it's the same thing, and you can get, given what they give you in the problem, you can get big M, the mass of planet Earth. And so I'll show you how here real quick, if you don't see it already. You cross out the little m's on both sides, and then G, in all physics GREs, we throw that as 10, simplify that as 10 as soon as we can, barring some other unusual reason not to, equals, and then I'm going to multiply by the r squared, m, and then I would just divide by the big G. So I've got 10r squared over G, and then I would start plugging in, because they do give us G. You do get G as one of the constants on the equation sheet. I know you can't see that, but you could use your equation sheet to get G as 6.67 times 10 to the negative 11th cubic meters, kilograms, seconds, blah, 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 blah. Look on the sheet for what the units are. We don't care about that. We just want this order of magnitude. So it's 6.67 times 10 to the negative 11th. I'm going to leave horrible technique there. Leave my units naked because I'm trying to save some time. And then R, they give us in the problem as 6.4 times 10 to the 6th. And that is squared. Okay, so I'm doing a bit of a quick move here to try and knock some stuff out. The 6 on the top, 6 on the bottom. I'm going to knock one of those, and so it's going to leave me with 1 6 on top. And then basically all I'm left with is the scientific notation, the units, or not the units, but 10 to the power of whatever. So you square this, you get 10 to the 12th times 10 is a 10 to the 13th on top. Because we had 2, this was squared, we had 6 blah 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 squared, we still have one of those. So we got 6 times 10 to the 13th on the top, and then 10 to the negative 11th on the bottom. And if you're good with your scientific notation, that pops out pretty quick as whatever those two numbers add to. I kid you not. If my eyes are crossed during this video, I'm that exhausted. So what does it come to? 24? 6 times 10 to the 24. Is that an answer? I hope so. I think it is. It is. Answer A is 6 times 10 to the 24th kilograms. So it's kind of a quick and dirty method to get that. You're just making some simplifications there and using some, little tricks. But the shortest, absolute best way to do that is to memorize some of these physical constants. Things about the planets like this, the sun perhaps, things about positronium, certainly. These are some of the things that at the graduate level you're kind of expected to have enough experience that you have some of this stuff memorized. So 6 times 10 to the 24th is the mass of planet Earth. I don't know what would help you remember that. There's 24 hours in a day on planet Earth. 6 times 10 to the 24. That help? Maybe? I don't know. That kind of helps me, I think. So that's that. That's an easy mechanics / astrophysics problem, and that was number 19 off of the 92 exam. As always, thanks for watching.